Hello and welcome to another tutorial of SystemVerilog in 5 minutes. Today we'll discuss about class. There will be several sessions to go through this. The first one here will cover the basic. Many people has told me that class is a difficult topic to master. I share their sentiment in terms of the difficulty level compared to other syntax, but in my opinion, class, like everything else, you just need to understand its concept to master it. So let's get started. These are several terminologies associated with class. Don't worry, I'm not going to go through this in an academic manner. I believe it is more important to understand what is class and what it is used for. Once you understand that, you'll be able to appreciate these jargons better. In the simplest term, class is used to create new data type. Look at this basic data type. This is a string. This is how you can use the string. Tuple is a built-in function for string. Similarly, this is a queue. It has several functions like pushback and sum. Now let's say you need a function to reverse the string from hello to alert. The native string type does not have that function. Similarly, if you want to get the average value of all array elements, the native queue also does not have that function. There are two ways you can get those functions. You can ask the committee to add them into the native types, or maybe you can create your own type. And this is how it possibly looks like. These are new user-defined types, and these are the functions they support. Of course, this code is not a legitimate code. This is just to give you the general idea. Now let's do it in the correct manner. You can use class to introduce a new type. This is the name of the new type. I call it statistics calculator. The prefix C is to show that this is a class. It should promote readability. Inside the class, you include variables and methods to operate on them. The example here contains an array queue and a function getMin to get the average. You can include other variables or functions, for example getMode, getMedian, and getStandard deviation. Similarly, you can create a class for the string, but for space reason, I'll simplify the string class. Now that you have these new types, you can use it just like any other types. Sc is a class variable or a class handle. You use dot operator to access the class members, for example the array queue and the function getMin. The only gotcha is you must initialize a class handle before you can use it. You initialize a class handle by calling new. If you don't, you get the null pointer error. Looking at this example, we created two classes, one for the array and another for the string. Each contains its own variables and methods. This is the concept of encapsulation, which is to group the variables and methods in a reasonable bundle as a class. You should not create one big class that supports both the array and string. You can, but that just doesn't make sense. Now let's study about the new function, which is also known as a constructor. Here is a dummy class cNumber. It contains a byte. Here you can create a class handle cn. Cn is null and it does not consume memory until you call new. It will then allocate memory based on the class. Since cNumber contains only 1 byte, it will allocate 1 byte of memory for it. And as you know, the byte is initialized to 0. After that, you can use the handle as you wish. If you want to customize the initialization of the handle, you can create a new function within the class. The new call here will refer to the new function in the class. For example, you can initialize the byte to 1 instead of default 0. Note that constructor function does not require a return type. It is meant to return the class it represents. You can also introduce arguments into the constructor. Just make sure that you call it accordingly. The constructor here passes the value 10 to initialize the byte. Now that we've understood the constructor, let's look into the concept of dynamic initialization. This example has no class handle. It has 2 bytes, A and B. We resort to pick A or B at the beginning depending on the input signal cell. You can see that regardless of which byte is chosen, A and B will always consume 2 bytes of memory. Let's say we introduce 2 classes to replace the bytes. The example will look like this. These are 2 handles instead of 2 bytes. We can use the constructor to instantiate the handle as needed. Only the chosen one is instantiated, and therefore only 1 byte of memory is in use. This is a similar example. Result is assigned to A and after that to B. A and B consume 2 bytes of memory at all time. If we use class, the example will look like this. A and B are instantiated only when they are needed. Even better, if you no longer need the handle, you can release the memory by assigning the handle back to null. In summary, class is used to create new type. A class variable or handle can be initialized dynamically. Next, we'll discuss about attribute of class members, including the concept of abstraction.